For our last video, we'll look at how to simplify a fraction that has a binomial in the denominator containing a radical. So this is why we reviewed conjugates in the last video. Since it turns out that when you multiply conjugates, all of the radicals end up canceling, that's how we're going to accomplish eliminating the root 5 from the bottom of this fraction. Remember that we want to multiply by a fancy form of 1 when we rationalize, and in this case our fancy 1 is going to be the conjugate of the denominator. Remember, the conjugate is when you keep almost the same binomial but you change the sign. So this was a 7 minus root 5 and it's going to become a 7 plus root 5. Okay. Remember how we multiplied fractions in elementary school, how we multiplied straight across the top and straight across the bottom. So our numerator is 12 times the quantity 7 plus root 5, and our denominator is 7 minus root 5 times 7 plus root 5. In the numerator, we're going to distribute the 12, and we're going to end up with 84 plus 12 root 5. In the denominator, we're going to distribute, and 7 times 7 is 49, and 7 times root 5 is 7 root 5, and negative root 5 times 7 is negative 7 root 5, and negative root 5 times positive root 5 is negative root 5 squared. Alright, so continuing to simplify here. Our numerator cannot be simplified anymore at this time, so we're going to leave that one the same. In the denominator, these middle two terms are opposites, just like the last time we did a conjugate, and they end up canceling out. 7 root 5 minus 7 root 5 is 0. And the root 5 quantity squared, remember a square root and squaring are inverses, so those cancel. And the square root of 5 quantity squared is just 5. And that gives us 84 plus 12 root 5 over 44. Now, one of the things I notice is that these fractions here would still reduce. I notice that 84, 12, and 44, they all have a common factor of 4. So what I'm going to do is I'm going to end up dividing them all out by 4 so that I can reduce this fraction. So if I do 84 divided by 4, that would be 4 times 21. And then if I do 12 divided by 4, that would give me 4 times 3. And 44 divided by 4, that would be 4 times 11. And then that allows me to cancel out all of these 4s. And then my final answer for this one would be 21 plus 3 root 5 over 11. We'll look at one more here. We've got to use a conjugate again. So it'll be root 2 plus 5 over root 2 plus 5 as my fancy form of 1. The only difference between this question and the previous one is that I have more distributing to do because the numerator is also a binomial in that original problem. So we're going to do 1 times root 2, which would be root 2, and then 1 times 5, which would be 5, and then negative root 2 times positive root 2. Now, root 2 times root 2 is root 2 squared, which means that's just a 2, and a positive times a negative is a negative. And then we're doing negative root 2 times 5, which is negative 5 root 2, all over. Now we've got to distribute our denominators. Root 2 times root 2 is root 2 squared, or just 2. And root 2 times 5 is 5 root 2. and negative 5 times root 2 is negative 5 root 2. And we've got a positive 5 root 2 minus a 5 root 2, and that equals 0. So remember how those conjugates work? That middle term is going to cancel out. And then I still have negative 5 times positive 5, which would be negative 25. All right, we've got some simplifying we can do here. In the numerator, the 5 minus 2, those are like terms. And the 1 root 2 minus 5 root 2, those are like terms. And then in the denominator, 2 minus 25 is negative 23. And we're just about done here, except for that it's usually considered improper notation to have a negative in the denominator. So to get rid of that, we're basically just going to multiply everything by negative 1. And that would just switch all the signs. So now we'd have a negative 3, a positive 4 root 2, and a positive 23. So our final answer, negative 3 plus 4 root 2, that entire quantity divided by 23.